Welcome! Today, we're going to tackle a really crucial step in your math journey, function notation. You know, if you've ever been staring at your math book, wondering why it suddenly switched from y equals to this weird f of x thing, well, you are in the right place. We're about to make it all click.
So why the big switch, right? Is it just to make things look more complicated? Absolutely not. This move from y equals to f of x is a serious upgrade. Think of it like going from a basic wrench to a full-on, high-precision toolkit. It just lets us say so much more with way more clarity.
Just take a look at this. On the left, that's your comfort zone, right? Standard algebra. You're asked to find y when x equals some number. Now look at the right. That's the upgrade. Find f of -3 is just a cleaner, more efficient way of saying the exact same thing. You already know how to do this. Function notation just packages it up for you.
Okay, this next part is so important. You have to understand that f of x is one single thing. F is just the name of the function, kind of like a recipe name. X is the ingredient, or the input. And the whole thing, f of x, stands for the final dish, the output, which is just our new name for y. And I'm going to say this a bunch. This is not f times x. It's not multiplication. Now listen up. If there is one thing you walk away with today, let it be this. I'm calling it the golden rule of substitution. Mastering this one little habit is the absolute key. It will help you dodge all the common mistakes, and honestly, it's going to set you up for major success when you hit calculus.
So here it is, the golden rule in 2 simple steps. Step 1, you create the skeleton. You literally rewrite the function, but every single place you see an x, you swap it for a pair of empty parentheses. Step 2, you drop in the input. After the skeleton is ready, you just drop your input value into every single one of those parentheses. It's that simple, and trust me, it forces you to be precise.
All right, enough talk, right? Theory is one thing, but let's actually see this rule in action. We're going to take it for a spin with a basic example. Okay, here we go. First, we write the skeleton, replacing the x's with empty parentheses. Then, we drop our input, which is -3, into each spot. And look, see how that keeps the negative sign safely tucked inside when we square it? That's key. So, -3 squared becomes +9. -4 times -3 is +12. You add it all up, and boom, our answer, f of -3 is 28.
So that was with a number. But what happens if the thing we're plugging in is, well, another algebraic expression? Does the rule break? Nope. And that's the beautiful part. The rule stays exactly the same. Let's check it out.
We follow the exact same process. First up, skeleton. Then we drop the entire expression, 2w plus 1, into those parentheses. After that, it's just basic algebra. We distribute the 3, combine our numbers, and we land on our final answer, 6w minus 2. See? The process doesn't care how complicated the input is.
All right, ready to level up? We're going to look at something now that comes straight out of a calculus class. It's called a difference quotient. Now, I know it looks a little scary, but I promise, it's just using the skills we've already been practicing. We're just putting the pieces together in a new way.
Okay, so think of it like building with Legos. First, we need to find our pieces. The big expression needs 2 things from us, f of x and f of 3. Well, f of x is easy. That's just the function itself, x squared. And to find f of 3, we just use our golden rule. Plug 3 into the function and we get 3 squared, which is 9. Simple enough. Now that we've got our pieces, we just plug them back into the original fraction. So where we saw f of s, we're going to write x squared. And where we saw f of 3, we're going to write 9. And just like that, our intimidating expression turns into something a lot more familiar, x squared minus 9 divided by x minus 3.
And now for the final step. We simplify. That numerator, x squared minus 9, should look familiar. That's a difference of squares. It factors into x minus 3 times x plus 3. And would you look at that? We have an x minus 3 on the top and on the bottom, so we can cancel them out. What are we left with? Just x plus 3. And I'm not kidding, this exact process is one of the absolute cornerstones of calculus.
So let's zoom out for a second and talk about the big picture. Why are we making such a huge deal about this one little habit with parentheses? I'm telling you, it's non-negotiable. Why is that?
Okay, everybody, lean in. This right here is the single most common and most costly mistake I see. When you follow the golden rule, you write parentheses -3 and parentheses squared. That tells you to square everything inside, including the negative, giving you +9. But without those parentheses, if you just type -3 squared into a calculator, it squares the 3 first to get 9, then it sticks the negative on. You get -9. A totally different and totally wrong answer. The parentheses are your shield. They protect you from this error.
And I know I said this before, but we have to circle back to it because it is that important. You have to burn the idea of f times x out of your brain. It's a single unit, a single name. You can't just divide by f to solve for x any more than you could divide by sine in sine of x. It's one whole symbol that stands for the result. And this isn't just for math class. In the real world, in physics, in engineering, in economics, this is the language people speak. I mean, look at that sentence. You could write all that out, or you could just write h of 3 equals 50. It packs all of that information. The function is height, the input is 3 seconds, the output is 50 meters, into one tiny efficient package. It's powerful. So what's the big takeaway here? It all comes back to a simple habit. Mastering the golden rule of substitution today, it's not just about getting the right answer on tonight's homework. It's about building the right kind of mathematical muscle memory. This one small habit now will save you from huge headaches on much more complex problems later on. It really is the small habits that pave the way for big success.